In this problem, we have a, b, c, three real numbers, and we will prove that a plus b plus c equals 0 implies a cubed plus b cubed plus c cubed equals 3abc. So let's just start. From here we have a plus b plus c equals 0 implies, taking c to the right side, a plus b is equal to minus c. And now, cubing the two terms, we will have a plus b cubed is equal to minus c cubed. Now we know that a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared, of course, plus b cubed, which is of course equal to a cubed plus, here we factor with 3ab times a plus b, of course, plus b cubed, and we will use this second form. So here this implies replacing a plus b cubed with this form, so it's a cubed plus 3ab plus 3ab a plus b plus b cubed is equal to, and minus c cubed is minus c times minus c times minus c. One minus will be left and c cubed. And this implies a cubed plus 3ab, but a plus b is equal to minus c. A plus b is equal to minus c plus b cubed is equal to minus c cubed. Of course, here a cubed 3ab times minus c is minus 3abc, of course, plus b cubed is equal to minus c cubed. Now the final step is to take 3abc to the other side and bring minus c cubed here. So we have here a cubed, of course, plus b cubed. Here we bring minus c cubed here, it becomes plus c cubed is equal to, and we take minus 3abc to the other side, 3abc. Now let's study the converse, meaning that if we have a cubed plus b cubed plus c cubed is equal to 3abc, does it imply that a plus b plus c equals 0? Of course, the answer is no, and the obvious counterexample is a equals b equals c equals 1. And in this side we will have 1 cubed plus 1 cubed plus 1 cubed, which is of course 3. And here 3 times 1 times 1 times 1, which is 3. But in this side, 1 plus 1 plus 1 is equal to 3. And it's of course distinct from 0. So this doesn't imply a cubed plus b cubed plus c cubed equals 3abc. Doesn't imply a plus b plus c equals 0. And this, of course, concludes our problem.